A number of elements are important to the understanding of perspective principles. The picture plane is a transparent plane on which the image of a three-dimensional object is projected. The drawing surface is the equivalent of the picture plane. The station point is a fixed point in space representing a single eye of the spectator. A horizontal plane passing through the station point intersects the picture plane and establishes the horizon line. The central axis of vision is the sight line that is perpendicular to the picture plane. The center of vision is the intersection of the central axis of vision and the picture plane. It lies on the horizon line. The cone of vision is a cone described by sight lines radiating outward from the station point and forming a 30-degree angle with the central axis of vision. A 60-degree cone of vision is assumed to be the normal field of vision within which the principal aspects of the subject occur. To minimize distortion of circular shapes, they should fall within a 30-degree cone of vision. A 90-degree cone of vision is acceptable for peripheral elements. The ground plane is a horizontal plane of reference from which heights are measured in perspective. The ground plane is a surface upon which the spectator stands. The ground line is a horizontal line representing the intersection of the ground plane and the picture plane. The distance from the ground line to the horizon line is equal to the height of the station point above the ground plane. For a normal eye-level perspective, the horizon line is at the standing height of the spectator's eye. The way sight lines radiate from the station point in perspective projection produces certain pictorial effects. The principal effect is the convergence of parallel lines as they recede into the distance away from the spectator. Consider a sight line from the station point extending to one end of a receding line. As the sight line tracks the receding line, the projections trace a straight line on the picture plane. If the receding line is extended to infinity, the projection of that line will continue until the sight line becomes parallel to the receding line. If another receding line parallel to the first is projected onto the picture plane, it will meet the end of the first projected line. This view shows the receding plane defined by the pair of parallel lines. A frontal view of the picture plane shows the projections of the two parallel lines converging at a common point called the vanishing point. The vanishing point for any set of parallel lines is the point where a sight line from the station point, parallel to the set, intersects the picture plane. This sequence illustrates how the vanishing point for a set of horizontal lines can be determined by drawing a sight line from the station point, parallel to the set, until it intersects the picture plane. If a set of receding parallel lines is horizontal in space, the lines will appear to converge at a vanishing point somewhere on the horizon line. A sight line from the station point parallel to the vertical axis remains parallel to the picture plane. Since the sight line never meets the picture plane, the set of vertical lines will not appear to converge in linear perspective. To review the principles of convergence, let's take a look at a single vertical plane and how its two sets of parallel edges appear in perspective. The top and bottom edges of the plane are horizontal in space. As the plane rotates about one of its vertical edges, the vanishing point for the pair of horizontal edges move, but always lies somewhere on the horizon line. When the plane becomes parallel to the picture plane, the pairs of edges are also parallel to the picture plane and remain vertical and horizontal. They do not converge, but each line will diminish in size according to its distance from the spectator. When the plane is rotated to a horizontal position, the receding edges become perpendicular to the picture plane and appear to converge on the horizon line at the center of vision. The near and far edges parallel to the picture plane remain horizontal. They do not converge. When the horizontal plane is rotated about one of its corner points, the vanishing points for both pairs of edges move as well, but they always lie somewhere on the horizon line. The vanishing points for both pairs of horizontal edges remain fixed on the horizon line even as we raise or lower the plane, as long as the orientation of the plane to the picture plane remains constant. Tilting the horizontal plane about one of its sides causes the vanishing point for the pair of sloping edges to rise and fall along the vanishing trace that passes through the vanishing point for the edges when horizontal. Being thoroughly familiar with the pictorial effects of convergence helps us understand how lines, planes, and volumes should appear in linear perspective, and how to correctly place objects in the space of a perspective drawing.